Hello YouTube, this is Frank and this is Wednesday, May the 6th, 2020, and this is my 23rd video and my 14th topical video, and this is on the coronavirus topic, and I'm looking at my predictions that I made back in the middle of April. Now, if you want to look at the groups that have made predictions, search for CDC coronavirus forecast, and that will show you the groups that the professional groups, the guys that have PhDs in mathematics or whatever, and have been doing this for 20, 30 years. That will show you the predictions of those guys. Now me, I'm Frank. I'm just using a simple model that you see in the differential equation books. This is you see the simple SIR model. This guy, Professor Paul Blanchard, he has a you can view his course for free on edX. I mean, there's no mystery. I mean, this is it's at the math is at the community college level. There's not higher math. I mean, there should be no mystery about this. So this is what I'm using a spreadsheet model. I'm using a 10-day moving average, and just look for Euler time step. Okay, I made back in the mid-April. You can see I think it was video 19 that I made my predictions, where I predicted the deaths for Florida, Georgia, and the United States. And so we looked on the if you look at the observed deaths, it's 1374 for Florida, 1675 for Georgia, and 64,283 for the USA. So that's I saved a copy. I mean, I saved the screenshot. Oh, here's my Raspberry Pi. I've had it going the whole time. I mean, it's been going for months, and it's just been saving all of my screenshots that I've taken, while I'm doing this video log or podcast. So let's just look and see what we've got. Let me put this here. Okay. I saved this. See, this was the forecast, and these were the models that were in the middle of April. They were predicting the deaths for May the 1st. And okay, I was predicting what, 81,000. So I mean, like, I'm in pretty much, I'm within the error bars of those models for those guys, that have been doing it for years, the PhD guys. Okay, so let's look at, so I saved for Georgia and Florida. Okay, there's Florida right there. Okay, I was predicting, 2,200. Okay, so see, I'm there, within the guys that are, within those models, the professional guys. Okay, for Florida, for Georgia, I was predicting 1,600. You see, I was a little bit. I'm within the range of those guys. The professional guys, and now I'm just using just a simple textbook algorithm to predict the deaths. Okay, let's see here now. What have I got? Okay, this is what I was predicting. Okay, where it is, right here. Okay, May the 1st, I was predicting 81,000 deaths. The observed on the CDC site was 64,283. So this is my spreadsheet. This is my simple SERV model. See, I'm predicting I'm kind of high on that, but the thing about it, look, this is the observed, and it's fitting good right here until it gets to there, and that's the social distancing. It shows that the curve is bending. I left the. Let's see. Let's go over here to my. See, I left all these constants. All of these the R values are constant. Throughout the whole month of April. I fit this curve to the month of April and just let it run. And the thing is, see, the social distancing bent the curve. So now if I were, okay, now it's back in, so I'm now in May. I'm looking at my data, I'm looking at my predictions, I'm looking at what what did I do to improve my prediction. And so what I want to do is fit that curve both. This is the observed curve. Okay, this is the first derivative. You can see, into mid-April, heck, I didn't know. I'm fitting the curve right there, but then it appears the curve is going back down. So what I need to do is to change my R values. So if I were, what I want to do is fit the curve to the observed data. So, okay, so if I were to change this, to 9.1. Okay, it didn't. I'm fitting that curve right there. That's the part that I'm in the beginning of. I'm at the end of March, and that's what I'm fitting right there. Okay, let's go. To the beginning of April. Let's see. If I go that to 7.8. I were to make that. Oops. Okay, see, I'm feeding that curve to the observed data. Okay, let's go to the next one. Okay, the beginning of April. Let's see. Oops, did I do that right? Oops. Let me make that 9.1 instead of 8.1. And look, I mean, also, I'm looking at the first derivative too. I mean, I'm trying to fit the first derivative and the observed data. So let's see. You can see that. See this column right here. Now that's not used in my calculations. That's just showing me what my old values were. I'm just keeping a track of my old values. See, there's 7.8, 7.8, 6, 6, 6, 6. So let's go here to the next one. Let me change that to 8.1. Okay, see, I'm trying to fit that data. See, I'm trying to fit that curve right there. I'm trying also to make sure that my first derivative is fitting. Okay, the next one. Okay, so, you know, at the beginning of March, we're seeing the social distancing. So let's change that to 4.3. Oops. Let's see, you know, I'm fitting that curve right there. I'm fitting the curve, the observed data, and I'm fitting the first derivative. And the first derivative is just, let's go over here to, okay. That's the observed data. The change in the observed data, that's the first derivative right there. That's just deaths per, that is the cumulative deaths. That's the deaths per day. That's the first derivative that I'm fitting. And I'm just eyeballing this. I mean, there are numerical methods that can make it more accurate, but I'm just eyeballing it. See, there's the curve I'm trying to fit. Okay, so if I were to change that. There we go. See, I'm fitting the curve to the observed data, and also the first derivative. Okay, the next one. Oops. Okay, the next one. Okay, I'm going to keep that. Oops, that's 3.7 right there. Let me get back up here. Oops. Okay, so I'm fitting that curve, and there's okay, the next one, this one here. All right, see, I'm bending the curve. I'm bending that first derivative right there. So let's go up here to there. See, I'm fitting the curve to the observed cumulative deaths, and then to the daily deaths. I'm fitting that curve right there. I'm bending the curve. Well, the people in the United States are bending the curve. They're doing the social distancing. So if I fit that to 3.6, see, I'm bending that curve right there. That's the first derivative. Let's go over here to the observed data. I'm fitting the curve. This is what the people of the United States have done. They've done their social distancing, and they bent the curve. That's what that means. They're bending the curve on that transmission of that disease. Let's see. Let's go over here. Now I did that for both. Well, for all 50 states, but I want to just show Florida, Georgia, and the United States of America. Okay, on June the 1st, I'm predicting 2,600 deaths, 57 for Florida, for Georgia, 2,280, and then for the United States of America, 111,000 deaths on June the 1st. So let's look at what the professionals have predicted. Okay. Oops. Let me see. So here it is, June the 1st. Let me get over here. June the 1st, 111,000 deaths. Now let's go over here. Okay, for the CDC. Okay, this is today. We look at just look at the forecast for the national forecast at the CDC. Okay, there's June the 1st right there. And there's all of these models, and these guys have all got PhDs, in math or physics or whatever. Okay, there's 100,000. Now I'm predicting 111,000. That's right there, with those. I'm using a simple model, a simple SURV model spreadsheet to predict these deaths. Let's see, over here, oops, if I got over here, there's all of the average of all of these models. It's over 100,000 for June the 1st for the whole United States. Okay, let's look. Okay. Yeah, there's that same graph. I saved that. I saved that so I can compare that whenever June the 1st comes along. We compare my predictions, the simple SIR model that you've got in the textbook, with all of these guys. These are all these universities, and and they've all been doing this for 20 years, 30 years. They've got PhDs. Okay, there's about right there is where I'm predicting for the U.S. Okay, for Georgia and Florida. Let's go down here. Okay, there's Florida, Georgia and Florida. Okay, I was predicting 2,600. See, I'm in there, certainly within a number of those models for Florida. Okay, for Georgia, I was predicting 2,200. See, I mean, with a simple model, well, simple SIR model, you can predict within, the ballpark of all these guys here. UCLA, MIT, Columbia University. I mean, all these. What's that? Los Alamos National Lab right there. So I'm predicting within the range of all those guys that have. I mean, I'm just using a simple model. The math is not above the community college level. If you can do community college level math, you can predict the deaths on those for that coronavirus. So let's just look again. Let's just look. Okay, and what am I doing? The R sub 0, that is the key to predicting those this curve. Let's see if I got a. Yes, right here. This is the. Have I got? Okay, this is the description of all the forecasts. If you go down there to the bottom, and this is on the CDC website. See, there's University of Texas, Austin. I mean, you can predict within. I mean, with using a simple spreadsheet, you can predict within. All these guys that are okay. Yang Gu. He shows you the R sub 0s, and let's see if this. Let me go over here to the fixing. Okay, there's the R sub 0s. Okay, whenever the okay, at the beginning of the period, the R sub 0s are 2.25 that they're showing for the U.S. And then for now, they're showing the R sub 0 is 0.9. Oops, 0.9. Now that is crucial to predicting the model, predicting the deaths. So look at what I'm doing. Look at what I'm doing. Let me erase. Okay, we've got the predictions. We can erase this. Okay. Now my simple spreadsheet, I'm using a 10-day sliding window. I'm using a constant infection rate, and then I'm varying the interaction rate. So right here, if we have the constant interaction rate is 2.5, and if you look in the literature, look at all look at the peer-reviewed articles. They say the R0 is 0.25, Okay, if we multiply by 4.0, okay, that is equal to 10 over 100, and that is equal to 0.1. Now I'm using a 10-day window, so if we multiply that 0.1 times 10, and that gets us the, an R value of 1. Now that, I mean, let's think about that. Let's think about that. Okay, let's go back to my spreadsheet. Let's see, let's get back over here. Okay, so if I change that 4.0, what should that, okay, what should this do? What should this slope of that do? It should be level. So let's calculate that. Oops, did I do something right? I did something wrong. 4 point. Oops, 0.0. Like a type. Okay. Four point zero. 2.5. Oops, that's not going to show. Let me go back to this one right here, because that's at the tail end of that. Well, if I were to, let me just go over here to this one. Let me get back over here. I'm going to leave that at 4. Oops. Was that 3.7? Instead, let's just change this. Data range to 78. There we go. Okay, that's what. The slope of that line is not quite 0. So if we were change it to, okay, did I change it? There we're bringing the slope up there. I thought it was closer to 4, but I may be wrong. The thing, okay, so what I'm doing is I'm changing the slope of that line. Okay, what I'm doing is changing R0. If R0 is 1, that is the number coming, the people that are infected coming in are equal to the infected coming out. And that is what that's what that is doing. So should be close to 4. But we'll see. Anyway, that's what I've got here. The other thing I wanted to mention was that in the recent days there was an alarm that the number of deaths on June the 1st, oops, let me get over here. Okay, there's the first river. The number of deaths on June the 1st could be 3,000. Now, how could that be? Let's go over here. Okay, let's just change that to what, 5. And what does our deaths look like? Okay, our deaths per day on June the 1st would be 3,100 if we change our social distancing to 5. So let's just check that out. That is going to be what? 2.5 times 5 over 1,000 equals what? We got a calculator here. Let's see, what do I do with my calculator? I should be able to do that in my head, but let's just make sure. .5 times 5 equals 12.5. Oops. Divide that by 10. That's 1.25. So if we look back at our R sub zeros, oops, what did I do? Okay, 1.25. I mean, that's within the average range. I mean, within the starting R sub zeros, you know, of all the states there. So that's not a bad assumption. So I mean, if the state started opening up and they have the R sub zero is 1.25, I mean that's well within the range of just the average. So we'll see how that you know, as states started to open up, if the now there's the R sub zero for the United States. We'll just see what happens when the states start opening up. So anyway, I've got my predictions. Not too bad on that. I'm within range of the major models, and we'll just see what we've got on June the 1st when I revisit this again.